So today we will learn about this Rutherford. So anybody tell me some, you know, what he did about Rutherford? Any idea? No idea? Okay, so we'll see. See, this is what this is the Rutherford diagram, right? These are what? These are the nucleus in this circle thing. And what is happening? This alpha particle is crossing from this nucleus. These are means these are the atoms. Okay, see, gold atoms. These are the gold atoms, and the alpha particles is passing from this atom. Now here, scattering of alpha particles by gold foil means my this alpha particle is going like this, and then what happened? This thing scattered, right? And now we will see some of the features of the Rutherford. So first is what? There's a positive charged, highly dense center in the atom called nucleus. This is what? This is nucleus, right? It's written
Yes.
that there's a positively charged, highly dense center in an atom called nucleus. Means if this is my nucleus, then if something is there in the middle, then obviously that's nucleus, right?
Yes.
Nucleus. This is my atom. So nearly the whole mass of an atom resides in its nucleus. So whole mass of atom resides in what? In nucleus, right?
Yes.
Now the electron revolves around the nucleus. We all know that electron revolves around the nucleus in a circular path. So now what is the third point? Here the size of the nucleus is what? 10 to the power minus 15 m, which is very small as compared to the size of atom. Means this is having the size of 10 to the power minus 15 m, and as compared to this is my atom is having 10 to the power minus 10 m, means the size of nucleus is very small as compared to the size of atom. Correct. So what he did actually, Rutherford suggested that this model of an atom was similar to that of a solar system. The different planets that are revolving around the sun. Similarly, in an atom, the electrons are revolving around the nucleus. So these electrons are called planetary electrons. So what happened in a solar system? Tell me. Earth means all the eight planets are revolving around sun, right? In the solar system. And here what is happening? That atom in an atom, your electron are revolving around the nucleus. This is my atom. The electrons are revolving around the nucleus. So this thing is similar to your solar system. So he gave this theory that first of all he gave what, that this is my atom. In the atom there's a center part which is known as the nucleus, and the electrons which revolves around the nucleus, and he gave the size also, size of an atom and size of an nucleus. So this is the basic one, we all know this, right? Rezi, we all know, na? You know this already, you know. Adham, you also, that which revolves
Yes,
around
ma'am.
which. So, see, what is the limitation of the other four model? Any charged particle, when accelerated, is expected to radiate energy. Okay, Razi, are you there? Hello? Razi, maybe your voice is not audible to me. Maybe some network issue. Razi, please join again. We'll wait for you.
Hello, ma'am. Can you hear me?
Yes. Hi.
Oh, ma'am, there was an issue with
Okay,
my mic.
Razi. Okay. Okay. So see, this is the limitation of Rutherford model. Now you know what is the limitation of Rutherford model. Any idea? Adham, what is the limitation of Rutherford model? Tell me.
Like a charged particle, like when it's accelerated, like it's expected to radiate energy. So like, uh, so like in the orbit, the electron should accelerate, so it should radiate energy, but and so uh uh so uh just radiate energy,
Oh,
so
okay, okay,
the
good.
revolving electron would like lose energy and fall into the nucleus. So
Okay,
I
and
guess if it was like
Razi was saying something.
unstable, the matter would not stable.
Unstable.
The matter would like I actually don't know. Like I just thought
Okay,
like
okay, okay.
matter would like not be there, but that's like that's.
Okay, and Razi, do you know anything about this?
Mom, I
What
forgot.
one?
I also I know another one.
See, see. First go through this first point, then you will get to know, and then you
Ma'am,
have to
it's there
explain
on
me.
it was
After
on the
that, I'll
screen the whole
explain it.
time.
What?
Ma'am, it was on the screen the
What?
whole time.
Who? You.
Ma'am, the limitations are on the screen the whole time.
Yeah, yeah, it's there. I know. That's what I'm saying. You have to go through this first point, and you have to make me understand. Okay? So go through this point. Read this and understand. Razi, Advika, Arham, are you there? Understanding, right?
Yes, ma'am.
Go through this first point right now.
So, ma'am,
Hmm. Explain me this first point.
mm,
Okay?
mm, it is
Try.
like
At
the
least
any
try.
charged
Hmm.
particle when it's accelerated to radiate energy to remain in a circular orbit. The electron would need to undergo acceleration, therefore need to radiate energy. Thus, the resolving electron would need to lose energy and finally fall into the nucleus. So, if this were if this were so, the atom would be highly unstable. Therefore, matter would not exist. But we know matter exists. It means that atoms are quite stable. Thus, it could not explain the stability of an atom. Stability of an atom when charged electrons are moving under an attractive force of positively charged nucleus.
So now explain me. Try.
Mm,
No? Okay, Razi, you?
Madam,
What? Yeah, yeah. Tell
ma'am,
me.
Ma'am Rutherford was not able to explain why and how the atoms were quite stable, ma'am, because the when the electrons are charged, ma'am, they started moving under attractive force of a positively charged nucleus.
Yeah. Anything else? Okay, so we'll go through this first point line by line, then you will get to know. So it's written that any charged particle, when accelerated, is expected to radiate energy. It's true, right? That if any charged particle will accelerate. Okay? If any charged particle, let's say this A is my charged particle, and this A is what accelerated, then it will do what? It will radiate energy. Correct? If we'll take example of a car, if we accelerate car, then what happen? Our speed increases. Correct? So it's same thing over here that if any charged particle will accelerate, it is expected to radiate energy. It will do what? It will radiate its energy. Now, to remain in a circular orbit, the electron would need to undergo acceleration. So, if your electrons would need to be in that particular orbit, so it should go under acceleration. Why? To radiate energy to be in that particular orbit. So now it's written that therefore it would radiate energy. Therefore, what it will do? It will radiate energy. Now, next is what? Thus, the revolving electron would lose energy, would lose energy and finally fall into the nucleus. Now, what will happen? If electrons are revolving, let's say, so what will happen? That it will lose its energy and it will finally fall into the nucleus. So, if this were so, the atoms should be highly unstable. So therefore, matter would not exist, but we know matter exists. So it means that atoms are quite stable. Not means atoms are quite stable. Thus, it could not explain the stability of an atom when charged atom. So the limitation, the summary of this paragraph is that Rutherford could not explain the stability of an atom when charged particles are moving under the attractive forces of any positively charged nucleus. How? First of all, we learned that any charged particle, when accelerate, it will radiate energy. So to be on that particular orbit, so to means to rotate on that orbit, it should undergo acceleration. So therefore, obviously, it will radiate its energy. So if the electron will revolve, then what will happen? It will fall into the nucleus. So if this scenario is happening, then what will happen? Then it means that your atoms should be highly unstable. है ना? So that's why this is the limitation of Rutherford, that he is not able to explain the stability of an atom, that how my atom is stable when charged particles are moving under this positively charged nucleus. And what is next point? Rutherford model could not explain the distribution of electrons in the extra nuclear portion of an atom. This Rutherford, one more limitation is what? That he is not able to explain the distribution of an electron. And what was the first one? That he could not explain the stability of an atom. Second, he could not explain the distribution of electrons. Okay? Razi, Advika, Arham?
Yes, ma'am.
Arham, simple now. First one is what? That could not explain the stability, means stability is first limitation. What is second limitation? Second limitation is could not explain the distribution. Distribution of what? Distribution of electron. So first is your stability of your atom, and second is distribution of your electron. So this is the limitation of your Rutherford model. So now we'll learn about this Bohr's model. So, any idea about this model? Any idea? See, here's what. This is my nucleus. We all know this is our nucleus, and what is around nucleus? All are the orbits. K orbit, L orbit, M and N orbit, right? We already know K, L, M, N. Arham, you know, right? K, L, M, N. What happened, Arham? Are you not feeling well?
Yesterday I was
Oh, why? What happened? Fever, cough, cold?
feeling
What?
fine. I had fever,
Fever.
feeling better.
And right now, feeling better?
Yeah.
Okay. Sad. You are not crying, right?
Now,
No, na? Okay, good. So next is what? This Bohr's model. So to overcome the objection of this Rutherford model, so next model is what? Bohr's model. So here, what is the first point? Atom consists of positively charged nucleus around which your electron revolves. What happened? Your electron revolves around your nucleus. Electron revolve in some certain permissible orbits, not just in any orbit. Means electron will revolve in your permissible orbit. It's not like electron will revolve here. No, it will revolve in your permissible orbit only. If it is K or L or M or N. So each of the orbits are associated with some value of energy. Each orbit will have what? Some certain amount of energy. Your K, M, L, N. So hence these orbits are known as energy shell. Now what is energy shell? Energy shell means that each orbit is having some amount of energy. That particular energy is known as, means that particular energy of your orbit is known as energy shell or energy levels. And this energy is fixed, which is known as the stationary state. Okay? Your orbits will have some amount of energy that is known as energy shell, and that energy is fixed, and that is known as your stationary state. Cool? Got it? Okay, next. So starting from the nucleus, it's represented as 1, 2, 3, 4. Means your K is 1, your L is 2, K is, just a minute. Yeah. So here is what? Here your K is 1, K, L, M, N means 1, 2, 3, and 4. So the electrons present in the first have the lowest energy. Means this will have the lowest energy as compared to your this one. This will have the highest energy. So energy increases on moving towards the outer. If we will move towards this one, if we will move towards this one, so what will happen? Your energy will increase if we will move towards the outer orbit. Okay. Next, energy of an electron remains same as long as it remains on the orbit, or it does not radiate energy while revolving. When energy is supplied to an electron, it can go higher. So, okay, for example, let's say here one electron is there. Let's name that electron as Arham. Okay, so Arham is Arham is electron over here in this first orbit, which is your K, K orbit. So this will have some amount of energy with respect to this particular orbit. Now, if let's say Arham will radiate to this orbit, okay, this is what L shell. So it will have more energy or less energy as compared to your K shell?
Ma'am,
more
more energy.
More energy. Why? Because your energy will increase on moving towards your outer shell. So this is the theory which he gave, your Bohr's model. First was what? The atoms consist of a positively charged which revolves around your nucleus. Second is what? Your each and every orbit is having some amount of energy that is known as your energy shell or your energy levels, and that energy is fixed, which is known as the stationary state. And each orbit is having a name of KLMN1234. If we will move towards this, so means if we are moving towards M, so M will have more energy as compared to your L, and N will have the highest energy as compared to your K shell. Okay, so this was easy, right? So what is this neutrons? First, let me go here where I wrote neutrons. Neutrons is having zero charge. We already know this. Neutrons, discovery of neutron is J. Chadwick. Okay, neutron charge zero, discovery is J. Chadwick. Now here, neutron is another subatomic particle discovered by Chadwick in 1932. It is represented by N. Will represent neutrons by N. So neutrons are electrically neutral particles as are having heavy as electrons. Means our neutrons is heavy as protons, which is equal to that of proton. Means his mass is equal to proton, right? Nucleus is equal to protons. So neutrons are present in the nucleus of all atoms except hydrogen. The mass of the atom is given by the sum of the mass of protons and neutrons present in that particular nucleus. So here, no, not this one, this one. I wrote somewhere that C. Where is it? Your number of electron is equal to number of protons. But here, okay. So this is what actually your neutron is discovered by this. First of all, you have to know that who actually discovered what. Second, it is representation is important. Third is what? This is electrically neutral particles and this is heavier as proton. Means the mass of these two is equal. And neutrons present in the nucleus of all atoms except the hydrogen, and the mass of an atom is given by the sum of mass of proton and neutron is what is the mass of your given mass of an atom. Mass of proton and mass of neutron is is what proton and neutron. See, this is what your mass of proton plus mass of neutron is actually a mass number. Okay, got it? So how to find a mass number? What we have to basically do? We have to basically add these two, your number of neutrons and your number of protons. So here this part is clear. Any doubt in this neutrons part or in this Bohr's model? Anybody? Razi, Advika, Arham? What, Razi?
Ma'am, can you explain again the Bohr's model?
Okay. Arham, you
Uh,
understood about Bohr's model? Okay, and Advika?
yes.
Advika, can you explain Razi?
Yes, ma'am. So I'm
Okay,
like,
try.
ma'am, you want me to explain basically Bohr's model, right?
Yeah.
Ma'am, can I like just have a second? Can I like just I just
Sure.
noted it down in my book. I just wanna like try to like find a way to
Okay.
explain it.
Razi, just wait for 2 minutes.
Yes.
It's very important to interact with with the children that explain this, then only he or she will get some kind of interest and studies. Otherwise, the class will get boring.
Ma'am,
Yeah. Go ahead.
yes, ma'am. So in this Bohr's model of atom, ma'am, first of all, it was like it was proposed by Neil Bohr, and it was basically to like get over the mistakes that were present in Rutherford's model. And the first in this is that the atom consists of a positively charged nucleus in the center, and uh, and it's positive because there are protons present in it, and there are electrons that revolve around the positively charged nucleus in specific orbits. And the second point basically states that each of these orbits has like a specific amount of energy present in it, and depending upon the number of electrons that are present in them, and these orbits are known as energy shells or energy levels. And from the center of the nucleus, like the orbits keep increasing and increasing, and they're like represented by alphabets or numbers like 1 2 3 4 5 or KL M and so on. Then and then the fourth point basically states that the energy of the first energy level of the energy shell like increases. So like it's the least in the first energy shell because there are lesser amount of electrons present there, and it keeps increasing till the last energy shell, which has the largest amount of energy because there are the most number of electrons present there. And yeah, that's all.
Okay, good. So, okay, Bohr's model. So, first point is what? That atom consists of a positively charged nucleus around which your electron revolves, right? This is what? This is my nucleus. And around nucleus, what will revolve? Your electron will revolve. So electron revolves in a certain permissible orbit and not just in any orbit. So if let's say this is my k orbit, L orbit, M orbit, N orbit, and here is my nucleus, and electrons revolves around the nucleus. Okay, so electron is having that much of permission that okay, that this electron is revolving in k, this is revolving in L, M, and N. It will not revolve here and there like here. No, it is fixed. Means electron revolves in certain permissible orbits. Okay, permission is given to each and every electron that you will revolve in this one, you will revolve in that one. Okay, so this thing is fixed. Now what is next? That your each orbit are associated with certain value of energy. Your this is having some value of energy, this is having, let's say, 2 3 4 5, I'm writing, let's say. So this is having some amount of energy, this is also having some amount of energy. Each and every orbit is having some amount of energy. That particular definition is known as your energy shell. And as the energy of an orbit is fixed, each and every orbit's energy is fixed. Each and every orbit will have energy, that is known as your energy level, and your energy is fixed, that is known as your stationary state. Stationary state means your energy is fixed as compared to each and every orbit. Your k energy is fixed, L fixed, M fixed, N fixed. Okay, Razi, till here understood?
Yes, ma'am.
Okay, next point is what? Starting from nucleus, what will happen? Your representation is like this: 1, 2, and 3, 4, or we can say alphabetic wise KLMN, your numeric wise 1, 2, 3, 4. The electrons present in the first energy level means this is my E1, okay? This is my E2, E3, E4. So now you will tell me E1 is greater or equal to E4. Means this arrow, this or this one. Which symbol I'll choose here? Tell me, first one, second one, or third one?
Ma'am, can you repeat the question? I couldn't.
Okay, so this is my energy E1, E2, E3, and E4.
Yes,
So if
ma'am.
I have to compare both the energies between E1 and E4, so which symbol I'll choose? The first one, second one, or third one? Because this is having more
One,
energy than this one. Na?
ma'am, E4. Ma'am, like the second symbol.
Second one, yeah, E4. Okay, yeah, good.
Because E4
E4.
has like more, and I meant to say
More
E4 has more
energy.
energy than.
Ah, yes. So that's what this point is telling us, that first energy level have lowest energy, and energy increases as you keep going outer the energy shells. Now this part also clear, Razi, that now if
Yes,
I'm
ma'am.
writing E4 and I'm writing E2, then this part is more. E2 and E1, then this part is more. E1 or E0 is not there. E1 or E3, then this part is more. Okay.
Yes, ma'am. Ma'am,
What
it
is
is
next?
like, ma'am, like,
Hmm.
when we move away from the nucleus, like orbit to orbit,
Huh.
like,
Hmm.
like, if by moving away from the nucleus, each orbit has some amount of energy, and they are greater from the previous one.
Yes.
Like the
Yeah.
outer one is greater than the inner one.
Hmm. Outer one is greater. If let's say here is having one motion, so this will have the highest energy as compared to this one also. Okay.
Yes, ma'am.
Okay. So as you will move further from this nucleus, your energy will increase. Next, energy of an electron remains same as long as it remains in the discrete orbit. So if let's say here my energy is somewhat like 2, so here if electron is there, so it will have 2 only. So but if electron will move to this orbit, so what will happen? Its energy will increase from 2 to 4 or 2 to 5. Okay, so its energy will increase. So and if that electron is in that particular orbit, its energy will same. But if electron is moving to the next subshell or next orbit, the energy of that particular electron will increase. Okay,
Okay,
got
ma'am.
it? Simple point. Now any doubt? Arham, where are
No,
you?
ma'am.
Arham, are you there or not?
Ma'am, I went to get water.
Okay, okay, you're not feeling well now.
Yes, ma'am.
Okay, so what is next? This is our last chapter, na? Structure of atom. After that, okay, so when you guys Half yearly exam done now?
No, ma'am, mine is going on.
Oh, going on. Science done?
No, ma'am. Ma'am, after computer we have science. Ma'am, like after this coming exam.
Ma'am, my
Oh,
result, ma'am, mine is done. The results also came.
okay. So how much you got?
Ma'am, my mother knows actually. I don't know. It came. I got it to know today itself.
So marks how much?
I don't know. I just have, my mother has it on a sheet of paper. Like,
Okay. Advika, what about you? Your half yearly exams done?
no, for computer I got full. For maths I almost got full.
Yes, ma'am. Mine got over last.
Acha, over. Okay.
Mom, I got
Okay.
full. Mom, I
Hmm.
got full in computer. I got almost full in maths also.
And science? Acha, no, no, no science. Na.
No.
What else?
There is
English.
EVS. EVS.
Okay.
English,
EVS how much?
actually,
EVS how much?
I don't know. For EVS, where
Don't know.
is it there? Let me just check. No, it's
Okay.
not on the website.
So Advika, till which chapter in your half yearly exam came? Till A&M or till, till which? Advika, in your half yearly exam, till which chapter of this chemistry came? Hmm.
Hello. Yes, ma'am.
Yeah, yeah.
Ma'am, for us, like only the first two chapters came in chemistry, ma'am, which is
Okay.
basically like everything
IMP and
just
MIS.
related to atom. Sorry. Yes, ma'am.
Hmm. IMP and MIS, no?
Elements and compound. Yes, ma'am.
Okay, so next will be A&M and SOA. So A&M is already done atoms and molecules, but you have to practice this thing. This is what? Okay. This is what? Tell me. Hmm? You have to go
Ma'am,
through
your
this
voice is
numerical.
breaking for
Okay, voice is breaking. Okay,
ma'am,
let
your
me
voice is
join it.
breaking for some reason.
Okay, okay, wait. Okay, so now how is it? Is it fine?
Yes, ma'am.
What happened, Razi?
No, I said yes, ma'am. Ma'am, when you asked about your voice.
Okay. So what is next? Next is your this thing, distribution of electrons in different orbits. Means how our electrons is distributed in different orbits, K, L, M, N, right? So this part is left, your valency is left. Only five topics is left now. So from this distribution of electron, this I'll start in the next class. Okay, today till Bohr's model I'm completing. So first of all, let's go through this. Arham, what are you doing?
Nothing.
Playing something.
No.
Yeah.
No, I'm not asking.
Okay. So, Razi, what about you? Means in half yearly exam, till how much chapter is coming?
Ma'am, two.
MIS, IMP. Okay, only two. These two is for
Yes,
finals.
ma'am.
Means in final, the whole
Yes,
four
ma'am.
chapter will come now, or only this two?
Yes, ma'am. Ma'am, whole four.
Whole.
Yes, ma'am.
Okay. Okay. So, and when is your final exam? Feb.
About it.
Maybe Feb or March.
Yes.
Ma'am, mine, I guess it's in like March and March beginning,
That's what,
maybe.
na? Feb last or March
February.
starting.
Yeah.
Okay. Good. Okay, so now you guys tell me any doubt in any of the topic. Charge one, your discovery of proton. This was the good one. Your discovery of proton, discovery of neutron, electron, Rutherford model. Any doubt in any of the model? Rutherford model, Bohr's model, Thomson model, not Thomson, only Rutherford and Bohr's. Any doubt?
No.
Sure.
Yes, I don't any doubt.
Okay, so in the next class, I'll start this distribution of electrons in different orbits. Acha, now, Acha, tell me any doubt in any assignment question?
I think I had one, but I don't know which one.
Aha, you don't know which one? Okay, Razid, any doubt in assignment questions?
No, ma'am. Ma'am, I think I did the last assignment and submitted it also.
Okay. Okay, Aram, tell me which question
I don't
is
know.
that? So check and tell, na?
What, ma'am?
Check and tell.
Um,
Acha, in physics and in biology, all the chapters done, Razi.
no, it's not. I think no.
So in physics, how many chapters remaining? Not in school here.
I know. I don't know how many physics. Maybe one. I
Okay,
don't know.
Razi,
Ma'am,
Razi, you tell me how many chapters is in.
in biology, the last chapter is running. Oh, it's. I mean, not the last chapter.
Ma'am, in bio, I think only one chapter is left. Ma'am,
No,
for
one
physics, I don't know.
chapter is left. In
Physics
physics,
alone. Physics two chapters
no.
remaining.
Ma'am, I don't know. I don't
Okay,
know.
okay. Hmm.
Or one.
One. Okay. Okay then. See you in the next
Bye,
class.
ma'am. Thank you, ma'am.
Bye bye. Thank you.
Thank you.
Bye, Arham.